Welcome back. Today we're moving from airflow and smoke to the second half of fire detection, heat detectors. While smoke detectors are the eyes of a building, heat detectors are the security guards for areas where smoke sensing just doesn't work. If you're a tech in the field, you need to know exactly which head to grab for the job, or you're going to be dealing with a lot of angry customers and false alarms. Let's get into the mechanics.
We don't put smoke detectors in kitchens, garages, or boiler rooms for a reason: fumes and dust. Heat detectors are built for these dirty environments. They are slower to trip than a smoke head, but they are incredibly reliable. Their job is to verify that a fire is actually present by sensing the energy in the room rather than just particles in the air. The most common type is the fixed temperature detector. Inside these units is a small silver metal link made of a special solder. This link is engineered to melt at a very specific point, usually 135 degrees or 194 degrees. When the room reaches that temperature, the link melts, the circuit completes, and the alarm trips. It's a simple mechanical process that hasn't changed much in 50 years because it works. Then we have rate of rise, or ROR. These don't wait for a specific temperature. Instead, they look for how fast the temperature is climbing. Inside is a small pneumatic chamber with a tiny vent. If the air in the room heats up too quickly, usually 15 degrees in 1 minute, the air inside the chamber expands faster than it can vent out. That pressure pushes a diaphragm, completes the circuit, and sends the signal. It's built to catch a fast-growing fire before the room even gets hot.
In the field, you'll most likely see combination units. These have both the ROR pneumatic chamber and the fixed temp solder link. This gives you the best of both worlds. It will catch a sudden hot flash fire using the rate of rise logic, but even if the fire is a slow smolder that doesn't trigger the pressure change, the fixed link will eventually melt and trip the alarm as a failsafe. Here is a professional tip. Never put a rate of rise detector directly in a commercial kitchen or near a large oven. Why? Because when that oven door opens, it releases a massive wave of heat. To an ROR detector, that looks like a fire. For kitchens, you stick with fixed temperature only. You want that detector to wait until it's a guaranteed 135 degrees before it shuts down the line. Garages and boiler rooms are the perfect spots for heat detection. These areas are naturally dusty and filled with exhaust fumes that would kill a smoke detector in a week. A fixed temperature detector doesn't care about dust. It only cares about the thermal energy. If you're seeing a lot of trouble signals in a dusty environment, check to see if someone accidentally installed a smoke head where a heat detector belongs.
The number one reason heat detectors fail in the field: paint. I cannot tell you how many times I've walked into a building and seen a white heat detector that's been painted over by a contractor. That layer of paint acts as insulation. It prevents the heat from reaching the solder link or the air chamber. If you see paint on a head during an inspection, it's an automatic fail. That device is now a paperweight.
When it's time for annual testing, put the lighters away. We don't use open flames. A professional tech uses a heat gun or a specialized blower. You apply heat to the side of the unit until the alarm trips. For rate of rise, you'll see the alarm hit almost instantly. For fixed temp, you have to be patient. Just remember, if you're using a heat gun, don't get too close. You want to test the sensor, not melt the plastic housing. Understanding the difference between fixed temp and rate of rise is what separates a parts changer from a real technician. Choose the right tool for the environment, keep them clean from paint, and always verify your trip points. If this guide helped you out, make sure to like the video and subscribe for more field-ready training. I'll see you on the next inspection.